what instantaneous rate of change is, so let's say we have a car, right? And so let's say it's traveling at exactly 8 a.m. So exactly 8 a.m. So we want to see, like if we have a camera here, we want to see at what time did exactly at 8 a.m. how fast was the car traveling exactly, not 1 second more, not 1 second less. So this is what is known as instantaneous. It's like a fancy word. Instead of saying average rate of change, this instantaneous means exact rate of change. So exactly of 8 a.m. And so how will a camera even know that? So the idea is that you get another camera for like 8:01 a.m. and then you kind of find the slope. But the real way to figure out without a camera would be to keep on decreasing this time. So instead of being 8:01 a.m., it'll be 8 a.m. but 30 seconds, 8 a.m. but 1 second. And so that's just basically the definition of a derivative. So using the derivative, we can find the instantaneous rate of change. And so that's like the instantaneous rate of change. So let's say we have a graph with like temperature and pressure. So given a certain temperature, there will be a certain pressure. So let's say at 10 degrees Celsius, the pressure is like, we're not going to worry about the units, but let's just say it's 100 pressure. So if we had like a graph, and so finding the exact pressure is also the same thing as like finding the derivative, and we would say it would be like units, this unit per this unit. So let's say this one is pascals. So if this is pascals, then we can say like, okay, if this one is degrees, so let's say this one is degrees. So then we can say degrees per Pascal. So that will be our instantaneous rate of change. You can say if we found the difference between these two. Like we wanted to find the exact at exactly 10 degrees. What is the pressure? And we see the graph is not like linear or anything. We want to find the instantaneous rate of change. What we do is we keep on decreasing the slope, and we're basically going to take the derivative. And the derivative, the units for the derivative will be degrees per Pascal. Because we are basically finding since we are finding like this is like the unit that we use when we want to kind of like describe the derivative.